Imagine a scenario where an asteroid is on a collision course with Earth. Sounds like a plot from a sci-fi movie, right? But this is a real and pressing issue that NASA is actively preparing for. Today, we're diving into NASA's cutting-edge strategies to address this cosmic threat. Recent studies and simulations are revealing how space agencies are gearing up to prevent or mitigate the impact of a potential asteroid strike. Stay tuned to discover how scientists are turning theoretical risks into actionable plans. Asteroids are small, rocky bodies that orbit the Sun, primarily located in the asteroid belt between Mars and Jupiter. Occasionally, their paths bring them close to Earth. While large asteroid impacts are infrequent, their potential consequences can be devastating. Historical records provide stark reminders of the impact an asteroid can have. For instance, the Chicxulub crater in Mexico, created by an asteroid impact around 66 million years ago, is widely associated with the mass extinction event that wiped out the dinosaurs. This incident underscores the significant threat that asteroids can pose. NASA is at the forefront of monitoring near-Earth objects to evaluate their potential risks. NEOs include asteroids and comets that come within proximity to Earth's orbit. To manage this, NASA tracks over 30,000 of these objects, using advanced telescopes and radar systems to gather detailed information. Key factors in assessing the threat level include the size, composition, and trajectory of the asteroid. This data helps scientists predict potential impact scenarios and understand the likelihood of a collision with Earth. NASA's efforts are focused on both tracking these objects and developing strategies to mitigate potential impacts. By evaluating the orbits and predicting possible future positions of near-Earth objects, NASA aims to ensure that any potential threats are identified early. This proactive approach is crucial for safeguarding Earth from the potentially catastrophic effects of asteroid impacts. NASA's recent impact scenario study focuses on simulating the effects of large asteroid collisions with Earth. This comprehensive study involves creating detailed models to explore various impact scenarios, factoring in different asteroid sizes, speeds, and potential impact locations. For instance, one simulation might examine the consequences of a 140-meter-wide asteroid striking a major city, evaluating potential damage to infrastructure and the impact on human populations. The study is designed to develop effective response strategies by understanding the possible outcomes of an asteroid impact. It considers multiple factors such as the force of the impact, the blast radius, and secondary effects like tsunamis and fires. For example, a simulation based on an asteroid similar in size to the one that caused the Tunguska event in 1908, a blast that flattened 2,000 square kilometers of forest in Siberia, could predict severe devastation to a large metropolitan area. By analyzing these scenarios, NASA aims to prepare for potential real-world threats. The study helps refine response plans, including strategies for evacuation, infrastructure protection, and potential deflection measures. This proactive approach ensures that NASA can provide timely and effective solutions to mitigate the risks posed by asteroid impacts. The implications of NASA's study are far-reaching. The data gathered helps refine planetary defense strategies and informs global preparedness plans. For example, if an asteroid were on a collision course, NASA would need to coordinate with international partners to develop a response plan. This could involve deploying space missions to deflect the asteroid or preparing evacuation plans for at-risk areas. The study emphasizes the importance of early detection. Identifying an asteroid threat well in advance provides more time for potential mitigation efforts. For instance, the earlier an asteroid is detected, the more options are available to alter its trajectory or prepare for impact. Addressing asteroid impacts requires global collaboration. NASA's study underscores the need for international cooperation in planetary defense. Space agencies such as the European Space Agency and the Russian Space Agency are key partners in tracking and responding to asteroid threats. International cooperation includes sharing data from tracking missions and coordinating emergency response plans. For example, the International Asteroid Warning Network is a global initiative to facilitate communication and cooperation regarding asteroid threats. By working together, countries can develop more effective strategies to manage potential impacts. NASA is actively working on several initiatives to safeguard Earth from potential asteroid impacts. The Planetary Defense Coordination Office plays a crucial role in these efforts. The PDCO is responsible for monitoring near-Earth objects, which are asteroids and comets that come close to Earth's orbit. This office tracks and characterizes these objects to assess any potential threats they might pose. By predicting the orbits of NEOs and evaluating their potential impact risks, the PDCO helps ensure that timely actions can be taken if needed. A key initiative by NASA is the Double Asteroid Redirection Test mission. Scheduled for launch, DART aims to test a method known as the kinetic impactor technique. This technique involves sending a spacecraft to collide with an asteroid to change its trajectory. Specifically, DART will target the moonlet of the asteroid Didymos, known as Didymoon. The goal of the mission is to gather data on how effectively this technique can alter the path of an asteroid. This information is crucial for developing future strategies to deflect potentially hazardous asteroids and mitigate impact risks. By combining advanced tracking technologies and innovative deflection methods, NASA is enhancing its capability to protect Earth from potential asteroid threats. These measures are essential for ensuring planetary safety and preparedness for any future challenges posed by space objects. In summary, NASA's preparation for a potential asteroid impact involves detailed simulations, international cooperation, and ongoing planetary defense efforts. The recent study highlights the importance of early detection and comprehensive response strategies. By refining our understanding and capabilities, we can better protect Earth from asteroid threats. Thank you for joining us to explore NASA's asteroid impact preparations. If you found this information valuable, please like, subscribe, and hit the notification bell for more updates on space science and planetary defense. Share your thoughts and questions in the comments below, and we'll see you in the next video.